So we're going to work our way through problem 20 from our homework. And how I like to approach these problems is we take the words that we have, we try to draw a picture to help us understand what's going on, and then we're going to make a roadmap to help us figure out how we want to solve the problem. So this problem tells us that we have an empty Erlenmeyer flask. So we'll draw a little flask here. This is a kind of flask that you might have in lab. We've got an empty Erlenmeyer flask. Empty, and it tells us that it weighs 241.3 grams. When we fill it with water, and I'm going to cheat a little bit and I'm going to copy my flask here so I don't have to redraw it. When I fill my flask with water, it has a different weight. I'm going to go ahead and just kind of fill this with water. And when we fill it with water, now its mass is 489.1 grams. So they also tell us that the density of water is 1.00 grams per centimeter cube. So the first part asks, what is the flask's volume? So we're going to call this, for part A, we actually can use this information from knowing the mass of an empty flask, the mass of a flask full of water, and the density of water to be able to figure out what the flask's volume is. Then we need to use that piece of information separately, because then we're going to fill it with a different substance. So in our next part here, we're going to take our flask and we're going to go ahead and we're going to fill it with chloroform. So chloroform here going to have a different density. So the density of chloroform is listed as 1.48 grams per centimeter cubed. So the density of this, again, is just lost it here, 1.48, there we go, sorry, 1.48 grams per centimeter cubed. So let's call this the B part. So what we need to figure out for part A here, part A is knowing the volume of the flask. Part B is knowing the mass of the flask with this additional different substance that's in there. So let's go ahead and sort of think about how we might have a roadmap for what we do here. So I'm going to split this in kind of half here to write our answers. So in this case, we can think about, we've got a flask that's empty and a flask that's full of water. And if I take the difference between those, I'll essentially get the mass of water. So I'll have my flask that's full minus my flask that's empty. That's going to be equal the mass of water. Now, once I have the mass of water, I can take the mass of water and convert that to a volume of water using the density. So again, density piece of information is going to come in here. So remember, density is a relationship between mass and volume. So if I want to convert between mass and volume, if I know the density, I'll be able to do that. Now, again, if we're looking for the volume of the flask, we're going to assume that if we determine the volume of water that completely fills that flask, that's going to be equal to the volume of the flask as well. So let's go ahead and see if we can just mentally see how the B part is different. Well, now, if we know the volume of the flask that we have, that we're again figuring out in part A, if we now know, and we'll assume that the volume of that chloroform is going to be the same, we can then use the density of chloroform to get the mass of chloroform. So then this problem will ask, how much does the flask weigh? So if we use this density piece of information here, this piece of density information, now I've got a lot of arrows all over my pictures here. This density piece of information will get us to the mass of chloroform. And then if we add the mass of the flask, that will give us the answer to this problem, which is how much will that flask weigh when it has a solution of chloroform in there. So I always encourage you, make some pictures, draw a roadmap, because when you see those pieces, it helps as we put stuff together here. So let's actually implement this process here. So we're going to have 489.1 grams, that's the mass of the full flask. When we subtract 241.3 grams, that's the mass of the empty flask, then we're going to get 247.8 grams. This is the mass of water. So 247.8 grams of water. Now I'm going to use the density, which tells me that 1 gram of water is 1 cubic centimeter. And mathematically, we really didn't do anything different here. This just tells me that I'm going to have 247.8 cubic centimeters of water, which is going to be the same as the volume of the flask. So for this problem, the volume of the flask, which is equal to the volume of the water, is 247.8 cubic centimeters. All right, so that's part A. Now we need to use that volume of the flask. Now we're going to know the volume of chlorophyll that will go in there. We can walk between the volume of chlorophyll and the mass of chlorophyll using the density of chlorophyll. And now that we know the mass of chlorophyll that's in that flask, we can add it back to the mass of the empty flask to get the sum of those two together. All right, so that's kind of walking through our map in words there, so let's sort of execute that. So we've got 247.8 cubic centimeters is the volume of our flask, so that's also going to be the volume of chloroform. So again, the volume of chloroform, we can walk between volume and mass if we have density. So in this case, we know that the density of chlorophyll was 1.48 grams per centimeter cubed. So my centimeter cubed gets a value of 1.48 grams. And so now I know that I am going to have 366.744 grams of chloroform. And so this problem asks us to think about what is the mass of the flask after we've put that in. So again, in this case, we're asking for sort of that sum of both of those. So we want the mass of the flask plus the mass of the liquid that's inside. So in this case, we're going to add the 241.3 grams, that's the empty flask, plus the mass of chloroform that we have. And notice I'm not rounding yet. I'm using as many significant digits as I can. We're going to end up with 608.044 grams. Rounding this to significant digits, we're going to have 3 significant digits. That significant digits are going to come from the density value that's provided. Okay, so we're going to round to 3 significant digits, and this is going to be 608 grams. Okay, so that's a solution for problem 20.